Hi everyone, in this video we are going to talk about building smart standards. In most cases people have only heard about IFC, but this encompasses a much larger range of formats. Today we will go over everything one by one and see which formats are ISO certified and which are not. One of the open BIM standards, as I already mentioned, is IFC. The medium for so-called data transfer. It is standardized with ISO. Then you have MVD, model view definition, which we will explain in more detail, but it is essentially an IFC filter. MVD is not ISO certified, but is closely related to IFC and the quality of data transfer. Then we have IDM, Information Delivery Manual, which is a description of the process. It is very similar to process maps, but in general it is more based on the IT sector for explaining everything behind software solutions. IDM is also ISO certified. Then we have IFD, International Framework for Dictionaries, which is implemented in the BSDD, Building Smart Data Dictionary. It is very characteristic because we can call it like a Google Translate for BIM, and it is also ISO certified. And finally, we have the BCF format, BIM collaboration format, which is used for sharing and sending tasks and is used to encompass the entire communication within BIM. You already have seen the slide, and this is what I mentioned in the beginning. IFC is a file format for transferring 3D geometry and object information, and it is considered the PDF of BIM or BIM PDF because it is an open format. It is in a container that serves to fill all the necessary information. I also mentioned that it does not meet the requirements of communication, and the previous slide shows that the requirements of communication within BIM will only be met if all these open BIM standards are present. Let's explain IFC a little more. IFC is a kind of empty container, but within IFC itself, its structure is very well arranged. Because of this, any software that generates IFC and any software that opens IFC can recognize it exactly as the first person designed it. This is possible because the information in that container is uniformly distributed and unchanged in terms of its structure. Now it is only important what the other person from the other side sent you and where the information will be deposited. So when we talk about IFC and its 3 dimensions, we are talking about 3 dimensions called IFC relationship, IFC object definition, and IFC property definition. What does that mean? It means that when you export a model or any element thanks to the IFC relationship, it will know for sure whether there is a certain grid next to the wall, whether that wall is on the first floor next to the door, whether a door is inside that wall, and so on. This is what the IFC relationship allows. Then the IFC object definition allows you to know whether there is a wall, a door, a window, etc. And the IFC property definition allows you to specify whether it is white, who is responsible, how much it costs, etc. Thanks to these 3 dimensions, it is also possible for you to know for sure whether it is on the first floor, whether it is a building A or building B, what its relationship is with other elements, etc. So it is a very cleverly structured container that allows you to always open it in the way the first stakeholder defined it, regardless of which software you used. The development of IFC began in 1995 and it developed from IFC 1 to IFC 4. You might hear about IFC XML or IFC zip formats, which contain a lot of non-geometric information. Today, the IFC 2x3 and IFC 2x4 formats are represented on the market depending on the software. Some software can export and import these formats, while others cannot, depending on their development. Since 2018, software certification has been taking place, which I already mentioned. And in the next slide, I will explain what IFC 2x3 means and what IFC 4 means. The same issue that often arises in projects and data exchange is so-called IFC limitations. That is the lack of proper exporting of IFC, which I already mentioned. A lot of unnecessary data is being exported. This is related to MVD, which I will explain to you. But it is also important to know that the main advantage of IFC is that if the IFC is sent, it should not be able to be changed after all. This means IFC is a file that should be locked by default. For example, if I'm an architect and I send my model to a structural engineer, I don't want the engineer to change my model. I want them to exclusively perform the structural calculation of that model. I don't want them to remove a wall or anything like that. And this is where problems arise due to not knowing what to do with the IFC. However, with IFC4, the possibility came that you can export something in the form of IFC and still have the ability to change it. It is important to understand that IFC is not a changing format. So if you want to change something, that person should send it to you in a native format. So if you work in Alplan, in Alplan format. If you work in Revit, the Revit format, and so on. IFC should be your end product. It should be a product that you put in the common data environment where all the models are connected. And what is the characteristic of MVD? MVD, the model view definition, represents the reason for exporting IFC. That is, what exactly you need to send to the other person to continue working on it. And this picture here shows it. So we have that IFC container, but it is not fully filled, only filled with information that the other stakeholder needs. Thanks to MVD, you can define what will be exported via IFC. You have MVD.xml today, which means the following. If an investor or you as a BIM manager know how to work with MVD, you can write under the Excel table what you want the person to export to you. Send it to the person who works, for example, in Alplan, and that person will import that Excel file. When exporting, they will export exactly what you wanted. That's a great thing with MVD. It tells you what information should be included and what should be excluded. It gives you that unique set of information. It is not the same if you want to export a project for structural calculation, for energy simulation, for architecture, for rendering, for cost analysis, etc. It's different, for example, if you want to export only cost items or only quantities. So it is very important which information to include and which not. This is related to MVD and related to IFC. We said that IFC is that container open format, and MVD is that filter that gives you certain information. Now, you have two types of IFCs on the market, IFC 2x3 and IFC 4. IFC 2x3 only offers you the coordination view. It only allows you to export IFC and not change it further. But IFC 4 gives you two types of views, the design transfer view and the reference view. If you export IFC as a reference view, it does not allow any changes. You can just send it so that other person can refer to your model, but if you send it as a design transfer view, the other person will be able to change the elements within the IFC. There are many different types of reports. For example, you can see how the model looks when you export it for a structural calculation, where only the load-bearing elements are included. This is how the model appears inside the software for structural calculation based on what you sent. It is very important to understand MVD because it is crucial when coordinating with several different models. It shouldn't happen that people send the same models, causing overlap and double quantities. You must know exactly what architect sends, what construction engineer sends, what structural engineer sends, and so on. This is defined within the BAP or BIM execution plan and through the MVD or model view definition. The IDM or information delivery manual is similar to process maps for the functioning of MVD and all export and import processes. It defines how to make a 4D BIM model and 5D BIM model also. IDM focuses on the background part of the IT sector, essentially a workflow diagram. For example, when you click a button, it determines what you will export. We will not focus too much on IDM because we will work on these process maps, which will probably make it so much clearer. The next is BSDD or buildingSMART Data Dictionary or IFD, International Framework for Dictionaries, and it is considered like a BIM Google Translate. So for instance, if I work in Alplan and draw a window in English, it will be called a window. If I transfer it via IFC to someone using ArchiCAD in German, it will be called a Fenster. This is possible because of BSDD, which translates elements automatically based on their properties. Different names for same objects ensure multinational cooperation and communication, even though many software solutions now offer multiple languages to overcome the language barriers. The next buildingSMART open BIM standard is BCF, the BIM collaboration format. Although not certified, it is one of the most interesting and useful open BIM formats. BCF closes the BIM communication loop, enabling reactions and comments from IFC into a native tool. For example, if we connect several models, such as a structural model, an architectural model, and HVAC installations, we can observe collisions. If you observe collision and want to assign it as a task to a construction or architectural engineer to fix, we do it through the BCF format. We mark the task, assign a responsible person, and send it. If you work in a common data environment, the person will immediately see the tasks. They can export the task as an XML file, import it into their modeling software, and the software will automatically place it in the same location, thanks to the unique code of each element showing what it needs to be fixed. BCF is an excellent format that allows you to see all errors and fix them, effectively building before the actual construction. Each element has its own global unique identifier. By drawing within Alplan or any other software, you automatically assign that global unique identifier to a certain element. This way, BCF recognizes that is the one exact element that you are looking for. So, for example, if a collision is discovered between a beam and an installation, the person receiving the tasks will see a picture, the time the task was sent, comments, who sent it, and so on. They can import the task into their native softwares to solve it. Inside the BCF viewer and any common data environment like BIM Plus, you can track open and closed tasks, what needs to be changed, and so on, which is great for coordination meetings. This format allows you to communicate any changes or adjustments efficiently. And another important format that appeared in the US is COBie, or Construction to Operation Building Information Exchange. COBie is a format for non-geometric information, mostly used for building maintenance. After the end of the project owner is obliged to deliver the information via XML for each installation using the COBie format. In the UK, this system is required to satisfy the BIM level 2. COBie consists of non-geometric data. It is essentially a large Excel table with a lot of information. Although it may seem incomprehensible and useless at first, it connects with certain elements in a BIM software or a BIM browser. By clicking on the element, you can access all of its information. And this slide and graphic illustrate what COBie is. Throughout the entire construction cycle, at the end, during the handover or transfer of the object, in addition to documents, the 2D drawings and geometry, you also deliver non-geometric information. And this is done via COBie to ensure the continued maintenance of the building. And yeah, that's all for now, and excited to see you in the next video.